Right folks, we've got the Major 3000. The trade customers in Ely, and he says don't forget to show where these came from, who the importers were, and I will do, and I might see if I can find the original address out of one of the magazines at the time. So Major 3000, they were going to do some other models, they never materialised. Odd prototype floating about, like the Major 4000. I think there's even going to be a base station. So they're Cybernet 134 set, they're a good radio. So where is it? Fullborn. Does come with the factory mic. And tell you what, we may as well use the factory power lead. He doesn't know anything about it. Says I, pondering for my Cybernet standard microphone. And it's dead. So, is it a duff fuse? Is it a non-existent fuse? It's a non-existent fuse. So we need a 20mm fuse, which is not normal. I will go and have to find one. What's the serial number? 112 00645. Right, we'll try again. Now with a fuse. Yay! Right, get it connected up to the test equipment. You know what, it could just be a retuning test. Right, we'll start with transmit, so put picture in picture on. Channel 20, put it on the 3 watt scale, just over the 3 watts. Let's put down 3 watts exactly. Channel 40. 2.9 watts, channel 1, 2.9 watts, back to channel 20, low power's probably on the back, it is, 100 milliwatts, backed in full power, current consumption 968. It's a lot of current for a small output for this type of set. So if it was tuned properly, I'd expect it to be 700 and something milliamps. So something's out there. Deviation for what it's worth on this test set. While it says 1, it probably is as well. We will be doing the VCO. Let's look at the frequency. And what have we got? Over to the frequency on the inset picture. 2779084. So it's starting to drop, but it's not illegally out. So I really need it to be over. It should be 79125. I really need it to be better than 100 to be able to send it back. Let's just hope the crystal isn't knackered, because we really are struggling with crystals. New ones never seem to work properly, and a lot of the old sets are knackered anyway. Right, it's back to the main meter and switch the SINAD meter on and put in the test equipment speaker and make sure RF gain's up. Tone to high position. Let's look at the frequency. 277912. Well, we're going to set it for what the radio's at. .084 or something. So it's a fair test. Oh my goodness, it's amazing. It's one of those best of the best sets. Squelch is a bit weak at 27 microvolts. It needs to really be 100 for maximum. And the sensitivity of squelch, set it for threshold. .3. Right, RF meter on transmit. It says 4.5, well it's doing 3, so that's lying. And the S meter should be reading S9 at 100 microvolts. He's a bit lazy. It's at 300 microvolts. Meter lamp works, switches work, potentiometers work, sockets work. Just need to check PA. Touching 1 2, touching 1 2. It does. That's that done. We'll get it opened up. I wasn't expecting this to be that good. "40 years old and working this well." it's lost a watt over 40 years. But I'm sure we can find it in there somewhere. May never have had that extra watt at the time. That's on a bit of a twist. I'll just put that out and back in again. So I instantly scanned for duff capacitors. I can't see any. See whether we can quickly find the notes for the VCO. I may have a memory like a sieve, but I think we're at 4 volts on these on channel 40. We'll go with that. The meter's not here. Okay, we'll come back to that. I know where the meter is. In the wrong place, of course. It's in the hallway. Testing. I found some realistic chargers the other day, which we bought and then promptly built chargers at the time. And so I thought I'll stick those on eBay, but I did want to just check they're doing an output, so hence the meter's gone for a little walk. Right, we'll go to the main meter on the test set, and we'll start with the transmit. And then, I reckon it's tea time. So the idea is the centre of the peak on channel 20. It's that one. You can find that amongst the wiring. That's the peak. So we need to get all these into what we call service mode. The service manual says that they want the set to do 4.4 watts in order to be able to balance this out. Never be tempted to leave it in full whack because it will obviously kill the transmitter, just like driving your car with your pedal to the metal would. Legality aside, and of course we're on a 4 watt system. That's up to 4.5 just. I don't think it's ever been fiddled with. Isn't that great? Just check those again. I'll try and be quick doing these because it will overheat. So we're just over the 5 watts. So now the idea is for the left hand yellow one to be clockwise to 4.4 watts. And then anti-clockwise with the green one. The manual says 3.8 watts, but we're around 4 watts, so we'll have what we're jolly well entitled to at 4 watts. They have to get it through customs. I don't. Right, let's see what we've got now. So on channel, I want it to be within 0.1 of the band edges. So channel 40, it's just over the 4. Channel 1, spot on the 4. We're talking about 4.02, you know, that kind of 4 on channel 40. So yeah, all nicely balanced. Thank you very much. And our current consumption on channel 20 is now 1.17 amps. So we've only gone up 100 milliamps to get an extra watt out of it, so that's balanced it nicely. Low power again, let's get that adjusted. Sometimes the preset needs cleaning. Yes, it's a case of the preset needing cleaning. Sometimes, if it's been used in low power a lot, you sometimes find that the preset needs replacing. About 1 in 30. So we'll waggle that about for the switch cleaner to get into that. And just get that adjusted to the central position. No idea why they did it like this. And set 100 milliwatts, 400 milliwatts, which is there just like that. 400 milliwatts. So we're going to do the RF power meter. So when I key up, I want it to be 4. It's what? It's in low power. Wow, that's well over. The preset there is the meter. Remember, it'll only read 4 watts when on a dummy load. Now I've set it to 4. When I put it on an error, it may read 1, it may read banging across. It's still doing 4 watts. I've had comments in the past, you know, when the meter's banging across. Oh, that's not doing 4 watts. Well, it is. So, we'll go on to the test set behind me. Put those expensive tools away. And we'll see what the deviation is. Wow, it's about 1.8, so it's a bit quiet. That's it. Right, I'll go and have my tea and then come back and we'll see whether we can get anything more out of this absolutely excellent receiver. The trouble is, my test set is 0.2 is the lowest it goes on this scale, then changes scales over, and then there's an inaccuracy. So I don't know whether we'll be able to read accurately where it is, but we're going to know it's less than 0.2. Okay, so got the multimeter back out of the hole, and where did I put the glasses? There. Test point is resistor 4 far side. We want channel 40. We want 4 volts. I can't remember whether it was 3 or 4. So this is 4 volts. I've always had a memory like a sieve. So we've got 4 volts there on receive. It doesn't need adjustment. I'm just going to pop it down that absolute ridiculous fraction. It's probably never been fiddled with in 40 years. And on transmitter it should also be 4 volts, and it is. So I'm going to put these 4 volts plus 4 volts, and it's now 4 volts plus 4 volts, because there we are. It was 2, I think I said. It's now 2.2 to 2.5 absolute peak, and that's now done. The trouble here, if you fail to do the VCO on some sets, they can drop off on channels, you know, like doesn't work above channel 37 or something like that, especially in different weather conditions. Some sets we don't know any technique for, so you just have to hope, but on these we do. So we don't get the extra stage on this set, we don't get the bigger speaker, we get the smaller filter. But I like these sets. Well, I don't think there's any Cybernet 134s I don't like. Right, time to do the receiver. Oh no, we'll put it on frequency first. Let's hope. Now, everybody cross their fingers. So now everything's warmed up, we're actually very close to it being acceptable. It's gone, done, spot on. So there's no cost there. And put the oscilloscope on. 2779125. I went and touched it and sent the frequency flying. So it's put 100 microvolts on the signal generator. We'll go over to the, it sounds a bit strangled, it does sound like the detector's out, and that could also account for its extraordinary sensitivity. But let's see whether it is or it isn't. It's very minute. Right, let's see whether we can get any more out of it. Go over to the SINAD meter, and we'll start with the first adjustment. Spot on. Bit more signal for the IFs. It's spot on. So we're going to get a different reading now. I have touched the detector, so it could be worse. Yep, it's 0.21. Let's change scales and see what it says on the other scale for 10. Yeah, it says 0.2. Because we've got this bit in between where it's a bit not ideal. Right, we'll do the S meter. It's a phenomenally performing set. It's that 1 in 1,000. You know, you could buy another 999 of these and they don't work as well. I'll tell you about my grandfather on my mother's side. He was into building radios with his brother. There we are, S9, in the 1920s and early 30s. And they built this radio set, somebody came to the house. I said, I'll buy that off you. So he thought about it. He thought, I can build another one. So he sold it. So he built another one. Didn't work anything like as well, because component tolerances back there were massive. So there you are. We are done, I think. Oh, just got the squelch to do. Yeah, it works. And we haven't tried. I'll test the mic on the air test. S meter is done, just a squelch. So put the squelch to full on the radio. And I want it to open at 100 microvolts. So if I have it as I have at 30 on, I'll show you the attenuator. Just like that. We are at 30 at the moment. There we go. Now I'm going to adjust this attenuator for 100 and it opens. That's where I want it. That's now set. So now we'll look at it at the other end. So we'll turn this down to 0.3 of a microvolt. Turn the squelch down on the radio. Set threshold. Signal generator back on. Still 0.3. I mean, some Cybernet 134s, it's 1 microvolt the squelch, but this one's 0.3. Again, that's exceptional. Do you get the 3-inch speaker or the 4-inch speaker on this? I don't know. What can I judge it with? I've got a tape measure on here. Right, I'll screw this back together and then we'll do a little test to the outside world. I'll just see if I can find any information about this, because I wanted to see if I could spot the importer's address. I'll be back with you in a moment. Right, so I'll just get this plugged into the roof aerial. One and a Roger. As usual, nothing. Yes, so when we look at this from Citizens Band magazine, March 1982, when we see the major, this is the major 3000, and they're suggesting there was a 2000, 4000, 5000. I know there was some pre-production ones. Unit 2, Station Yard, Wilbersham Road, Fulsham, Cambridgeshire. I'll just show the 3000. So I thought we'll have a look on Google. So I'm assuming that Station Yard would have either been here or there. Got some buildings here, some there, and so looking at the street view from this angle, from Station Road, I'm assuming this is Station Yard. So you've got two warehousey buildings and a brick building there. and a porter cabin, so presumably the wholesaler was, the importer was there. There we are, bit of looking up research there. So Major 3000, and the only actually one they sold. I know there are some prototypes of some of the other majors, which didn't make it to market. Thank you for watching, that worked out really well.